All right, guys, we're going to cover some inequalities today, and hopefully a lot of this is just review. But here's the thing. With these inequality symbols, it is going to be very important that you understand that depending on which direction you're reading them from or interpreting them from, left to right versus right to left, could change what they mean. Okay? So, with the way that you see them up on the screen right now, you guys are going to be most familiar with interpreting these from left to right. Okay? And that's fine. And that's probably going to be the favorable way to do this. Okay? So that... Uh-oh. What the heck? Hang on. All right, here we go. Back at it. All right. That first inequality symbol, how would you guys interpret that?
Less than. Greater than.
That is greater than.
Greater.
That is greater than. Okay? Now, I don't know how you guys were taught, all that kind of thing. We need to be able to interpret these by looking at them. But just remember that the alligator mouth or whatever you want to call it, okay, always opens to the bigger thing, okay? So that first symbol from left to right is greater than. Therefore, the next one is less than. And again, guys, this is left to right now. We're interpreting these from left to right, just like we read. What would be the next one? Less than or equal to. Okay, less than or equal to. If it has the little bar underneath it, which is kind of half of an equal sign, if you want to look at it that way, that is your or equal to. And of course, the next one is what? Greater than or equal to. Okay? So that's going to be the first thing we've got to be able to do is interpret these correctly. And that is how they are interpreted from left to right. Okay? Now, the other thing that you're going to have to be able to do today, or you're going to need to be able to do, is you're going to have a graphical representation of these inequalities. Okay? What does it look like on a graph? And with that is going to come either an open or a closed circle. Okay? With greater than and less than, these two right here, those are going to require an open circle. Greater than and less than will require an open circle on the number line when you graph these inequalities. What an open circle means do not include. Do not include that value. Okay? An open circle means do not include that value. So therefore, less than or equal to, greater than or equal to, is going to require a closed circle. Which means to include that value. Okay? So open and closed circles are going to come into play here. Open circle for just less than, greater than. Bless you. Closed circle for less than or equal to, greater than or equal to. Open means do not include. Closed means to include. Yes?
So, for to include the value, does it apply to both less than or equal to, or would
Correct. If it's or equal to, you will include. Okay. Everybody good? Does everybody have this down? Okay. All right. Here's the other thing that we've got to remember with inequalities when we solve these. Okay. When do you flip the inequality? So when we're solving an inequality, depending on what we do, that inequality may need to flip. Okay? When do we flip an inequality? Does anybody remember? If we multiply or divide by a negative. Guys, if we are solving an inequality and you multiply or divide by a negative at any point, you are going to flip the inequality. Multiply or divide by a negative at any time, we're going to flip the inequality. Okay? Now, most of the time, these inequalities, we're going to solve them just like we do our equations. It's the same procedure, so to speak, but we've got to kind of keep this multiply or divide by a negative thing in the back of our mind, saying, hey, did I ever do that? If I did, I'm going to flip it. Okay? All right, everybody got it? We good? Okay. All right, so let's do a few of these. Okay? Let's graph. Now, when you read these inequalities, you need to be able to read them from the variable, from the letter, to the number. So this one here, we're going to read from left to right. And we're going to read that as x is less than 4. X is less than 4. So, what this inequality is saying is that x represents numbers or values. What are values less than 4? What does this look like on a number line? So here's what we're going to do. Draw your little number line. Put a 0 on there. Put a 4 on there. Now, less than, open or close circle. Less than, open or close circle. Less than, open or close circle. Open. You're going to put an open circle around 4. Which way on that number line are you going to find values that are less than 4? You're going to go to the left or right? You're going to go left. So you're going to draw an arrow to the left. That is now a graphical representation of all the values that are less than 4. And there's an open circle around 4 because you cannot include 4. 4 is not less than 4. 4 is equal to 4. It's not less than 4. That's why we cannot include the number 4. That's why we have an open circle there. Okay? So that's where the open and close comes in. Values less than 4, there it is. Open circle around 4, arrow to the left. Now we have a visual of what's going on with the inequality. Okay? Everybody okay with that? Okay, next one.
We still didn't solve it. We didn't solve for what x was talked about.
X, it's already solved right here. So X is all by itself on one side, so it is technically solved. It's good to go. Okay?
So we don't have to identify what x is.
No.
Nope. X represents all numbers. So right here, if we read this from x to the number, what is this describing? X is what? X is greater than or equal to negative 3. X is greater than or equal to negative 3. So we're going to go number line, 0, put a negative 3 on there this time. Guys, we don't need a bunch of tick marks. Okay? I would get a 0 on there. That way we know where the negative and positive side are. And then I'm going to put the negative 3 on there. Open or closed circle for this one? This is a closed circle. Very good. Because this is an or equal to inequality. So we are going to include negative 3 this time. Where would you find values that are greater than or equal to negative 3? To the right. Closed circle around negative 3, arrow to the right. We now have a visual representation of this inequality and all the values that would be greater than or equal to negative 3. And we include negative 3 this time because negative 3 is greater than or equal to negative 3. That is a true statement. Okay? Guys, if you see a little line underneath that inequality, it's going to be a closed circle. That is an or equal to situation. Okay? Let's do this one. For some reason, anytime 0 gets involved, that seems to give us trouble. What is this inequality saying? X is greater than 0. Number line, put a 0 on there because that's the only number involved here. Open or closed circle? Open. Open circle around 0. Which direction? To the right. Values greater than 0 are going to be found out there to the right. So again, guys, 0 is fine. Okay? And like I said, a lot of times when 0 shows up and stuff, it gets kind of confusing. Hey, values greater than 0, open circle around 0, arrow to the right, done. Okay? Let's go to this one. Now, what do you notice? What's different about this one? It's reversed, okay? Guys, remember, try to read these from the variable to the number. We're going to have a lot of people that look at this and they're going to say 5 is greater than X. And that is correct, okay? But what is this inequality saying? We want to read it back this direction from the right to the left and say X is less than 5. Guys, this inequality is describing values that are less than 5. And like I mentioned when we first started, it really depends on which direction you read from on how these inequalities can be interpreted. Is that a greater than symbol? Sure, from left to right. But from right to left, it's a less than symbol. And we need to understand that, okay? Try to read these from the variable to the number. Values less than 5. The alligator opens to the bigger thing. So 5 is going to be bigger than whatever X is. So here's what we're going to do. Put our 0 on here. Put our 5 on here. Open circle. And which way do you find values less than 5? Back to the left. The arrow will not necessarily point the same direction as your inequality. A lot of students kind of get in trouble with that because that's all they start looking for. Guys, try to make sure you understand what the inequality is saying. Try to read it from the variable to the number. X is less than 5. This is describing values less than 5, but not including 5, hence the open circle. Okay? So that doesn't happen a lot, but just kind of keep that in mind. If you see it somewhat backwards, we need to try to get it to where we can interpret that the other way. Okay? Any questions there? We okay with that?
Yep.
Okay. All right.
Oh my gosh.
Okay, so let's solve a few here. 3x plus 2 is less than negative 4. 3x plus 2 is less than negative 4. And again, we're going to solve these just like in an equation, but because we have an inequality, we're going to try to keep in our mind that if I multiply or divide by a negative at any point, we are going to flip the inequality. What would we get rid of first here? How? There you go. Subtract 2 from both sides.
It goes 1x. It goes 1x plus.
Subtract 2 from both sides. That's going to give us 3x is less than negative 6 now. Negative 4 minus 2 is negative 6.
3 minus 2 is 1.
How do I solve? Last step. Divide both sides by 3. We are dividing with a positive number. We are dividing by a positive number. We're dividing by 3. It is positive. The inequality will stay the same. Now, what's negative 6 divided by 3? Negative 2. Our result is negative. That's fine. How did we get there? We divided with a positive number. That's why the inequality stays the same. It doesn't matter how the answer comes out. Positive, negative, doesn't matter. It's how you get there. X is less than negative 2. We have now solved it. Number line. 0 and negative 2. Open circle. Which direction? Values less than negative 2. Which way do you find values less than negative 2 on a number line? To the left. Okay? So a little bit more involved here. We're going to have to solve the inequality, and then we're going to graph that solution set. That's the thing that's a little bit tougher with inequalities is you're talking about sets of answers, ranges of answers. Question?
Can you go back one slide? I want to see if I missed something.
I'll come back to it. Well, it'll just keep going. Well, I'll get you back. Okay, does everybody have this one? Is everybody good? Let's take a look at this one. Let's throw a little bit of a fraction in there. X over 6 plus 2 is less than negative 1. What are we going to get rid of first? How? Subtract 2 from both sides. Pardon?
Put negative 3 over 1. I don't know. We'll put negative 3 over 1.
Negative 1 minus 2 is going to be negative 3. So now we have x over 6 is less than negative 3. How do we get rid of that 6? If that is x over or x divided by 6, there you go. Let's multiply both sides by 6. If x is being divided by 6, let's multiply by 6 to undo it. There on the left side, the 6's cancel, and you're left with x. Did we multiply with a positive or a negative 6? Positive 6. Therefore, the inequality stays the same. And what's negative 3 times 6? Negative 18. So again, because the 18 is negative, That's not going to flip the inequality. It's how we got there. We got there by multiplying by 6, positive. Inequality stays the same. Number line, 0, bless you. Negative 18. Guys, that's all we need on the number line. Keep it simple. Open or closed? Open. Direction. Values less than negative 18 would be back to the left. There it is. There's your graph. Open circle around negative 18, back to the left. We now have a graphical representation of our solutions. All right, has everybody got it? There you go. Okay, there we go. Negative 7x plus 8 less than or equal to 1. Negative 7x plus 8 less than or equal to 1. Can you see what we're eventually going to divide with? We are eventually, you take a look, we're solving for x here. Take a look at what's sitting in front of that x is a negative 7. Guys, you're eventually going to divide with a negative 7 here, okay? Now, if you can kind of foresee that, you need to start thinking, okay, here's one where I'm going to have to flip the inequality, okay? Now, that's just, like I said, it's one of those things we've got to kind of keep in our mind. Now, what's the first thing you're going to get rid of, though? What's the first thing we need to get rid of? Subtract 8. Agreed. Cancel the 8s. Negative 7x is less than or equal to negative 7. Subtract 8. 1 minus 8 is negative 7.
I know it will, so I'm not gonna, how would you do it?
Oh, we're not done yet. Oh, hang on. Okay. What are we going to divide with?
7. Negative 7.
Negative 7. And we are dividing with a negative number. Therefore, the inequality is going to flip. That inequality is going to flip because we are dividing with a negative value. And negative 7 divided by negative 7 is positive 1. Guys, if we don't flip that inequality, it drastically changes the solutions, okay? Instead of values being less than or equal to 1, it is now values greater than or equal to 1. That solution set is completely different than the other. So here we go. Let's go number line. We're going to go 0 and a 1. This is going to be a closed circle, correct? It's an or equal to, so we are going to include the number 1. And where do you find values greater than or equal to 1? To the right. Guys, the majority of the time, you will probably be interpreting these inequalities from left to right where we are most comfortable. But I'm just telling you, we need to be prepared to read them back the other way. That interpretation can change based on the direction you are looking at it from. Okay? Are we okay there? Questions? In just a moment. And then Kaylee's going to go first. Okay, all right, here's what we got. That first section right here. Guys, that's kind of what we did earlier. They're going to give you an inequality. You're just going to do the graph of it. Put it on the number line, open or close circle, arrow to the right or the left. Okay? All right? Next section. Take a look at, and I know the copy quality was not great. Take a look at number 5 there. And by the way, number 5, that is an open circle. Whew. That's an open circle around -6. And that arrow's going which direction? To the left. So this would be x values that are less than -6. So you're looking at a graph and being able to say, hey, here's the inequality that this graph represents. Okay? But that's what you're doing in that section there. So the graph is in place. You're trying to come up with the inequality that matches the graph. Okay? And then after that, okay, here's what we're going to do. We are going to go, I'm going to pick and choose a few here. We're going to go 2 to 8 even. So jot that down, 2 to 8 even. 2 to 8 even. You guys are just getting into solving these inequalities, okay?
How many do we do?
9 to 14 all. 9 to 14 all. $17 and $18. Okay? So 2 to 6 even. Oh, I'm sorry, was that right? 2 to 6? 8, sorry. 2 to 8. 2 to 8 even. 9 to 14 all. 17 and 18. I think those will keep you in the realm of what we looked at example-wise.